Hello everyone, welcome. So we are seeing previous year solutions of UPSC Mathematics Optional. So we are in linear algebra, right? So in the previous class, we have solved problem number 1, right? So in this class, we will start problem number 2, right? So we're going to see almost last 10 to 12 years solutions. So if you haven't watched the previous video, go through that and come back to this video, right? I have also completed linear algebra fully. If you haven't watched my linear algebra lectures, you just go through the description box. I'll just attach all the links in the description, right? Super. So now we'll move on to problem number 2. Again, very easy problem, very standard problem, right? So we need to find the matrix for the corresponding linear operator. That's it. So very simple. So they have given the basis, right? So find the matrix associated with the linear operator V3 of R defined by T of A, B, C is equal to A plus B, A minus B, 2C with respect to the basis 0, 1, 1, 1, 0, 1, 1, 1, 0, right? Very simple. So you know how to find the matrix for the corresponding linear transformation, right? So very simple. So we will start, right? So if you have watched my linear algebra lectures, you can do this in 10 minutes, right? No problem. So we will do this. Okay. So we'll start with solution. So what is the linear operator here? So what is linear operator, right? If it is a map B3 of R to itself, it is linear operator, right? Okay. So they are given a T. So T is from V3 of R to V3 of R. That is, it operates from V3 of R to itself, right? So the given linear operator T is, so it is V3 of R. So V3 of R is same as R3 of R, right? So V3 of R to V3 of R, right? So the given T is V3 of R since the linear operator map to itself. So hello everyone, welcome. So we have been seeing previous year solutions of UPSC Mathematics Optional. So we are in linear algebra, right? So in the previous class, we have solved problem number 1. So in this class, we'll move on to problem number 2, right? So I have already completed linear algebra fully. So if you haven't watched my linear algebra lectures, I'll just post all the links in the description box so that you can watch those videos, right? Okay. So in the previous class, we have solved problem number 1, right? So in this class, we'll move on to problem number 2. So first, we are starting with 2021 paper. And in the upcoming class, we will solve 2020, 2019 and so on, right? Okay. So again, very simple problem, very standard problem. So we need to find the matrix for the corresponding linear transformation. So they have given the basis also, right? So very simple. So find the matrix associated with the linear operator. So they have given linear operator, that is V3 of R to itself, right? So V3 of R defined by T of A, B, C is equal to A plus B, A minus B, 2C. So with respect to the given basis, right? So 0, 1, 1, 1, 0, 1, 1, 1, 0. So very, very simple problem. But it will take time, right? So you need a practice to do this problem very quickly, right? Okay. So first, what is the map they have given? So they have given a map T from V3 of R. So V3 of R to V3 of R, right? So since it's a linear operator, it maps to itself. So I'm taking T to be V3 of R to V3 of R, right? Okay. So what is, so this map is defined by, so T of A, B, C, right? So if you give an input vector, so input vector is a element in R3, right? So element in R3 because our V is R3. So V3 of R is same as R3 of R, right? Okay. So T of A, B, C is equal to A plus B, A minus B, 2C, right? So if you give an element in R3, it will give the output as A plus B, A minus B, 2C, right? For example, T of 1, 0, 0. If you give an input 1, 0, 0, output will be 1 plus 0, 1 minus 0 and 2 times 0, right? Because our A, B, C is 1, 0, 0. If you give an input 1, 0, 0, output will be like this, right? Very simple. Now we need to find the corresponding matrix for this linear transformation, right? For this linear transformation. How to do? Very simple, right? So first, they are given the basis as 0, 1, 1, 1, 0, 1, 1, 1, 0. If they give only one basis means, you take that as a basis for the domain space as well as column space, right? Suppose if they give basis for domain space separately, basis for codomain space separately means no problem. If they give only one basis means, you assume that as basis for the domain space as well as codomain space, right? Here both are same because it's a linear operator. So domain space is V3 of R, codomain space also V3 of R, right? So that means you take this as a basis for domain space as well as codomain space, right? Suppose in an exam point of view, they can also give a different basis for domain and different basis for codomain, right? But in our problem, they are given only one basis. So assume that you take that as basis for both the space, right? So since it's a linear operator here, no problem. Okay. So first, what you need to do is, you just input these basis elements, right? So very simple, right? You know how to find the matrix for the corresponding linear transformation. So first, what you have to do is you just take the first element in the basis. So you just find it, right? You just input this first element in the basis 0, 1, 1, 0, 1, 1, right? So what will be the corresponding output? So T of A, B, C is A plus B, A minus B, 2C. So what is A plus B? So A is 1, B is 1, C is 1. So A plus B, A minus B, 2 times C, right? So therefore, the output is 1 minus 1, 2, right? 1 minus 1, 2. Now, you need to express this vector as a linear combination of what? You need to express this vector as a linear combination of bases in the codomain space, right? Now, you need to express this vector. Right? So, output vector is 1 minus 1, 2. You need to express this as a linear combination of the basis of codomain space. So here what is our codomain space? It is V3 of R. So since you are given only one basis, you can assume that to be basis for domain space as well as codomain space. Now you need to express this as a linear combination of the basis of codomain space. So basis of codomain space also this is only, right? So 0 times 0, 1, 1 plus y times 1, 0, 1 plus z times 1, 1, 0, right? Very simple. Now you need to find this xyz. That xyz will be the first column in the required matrix, right? Now what I have did, I have taken the first vector in basis 0, 1, 1. The output is 1 minus 1, 2. You need to express this output as a linear combination of elements of the basis element in the codomain space, right? So here codomain space also V3 of R. So since you are given only one basis, you take that as a basis for codomain space also. So I'm expressing this vector as a linear combination of this for linear combination, right? X, Y, Z. So you need to find the corresponding X, Y, Z. That X, Y, Z will be the first column. That X, Y, Z will be the first column in the required matrix, right? Super. So you need to find X, Y, Z, right? So very simple. This will lead to a system of equations. If you solve the system of equations, you can easily get the answer, right? Okay. So what I will do is, so you just equate, right? Very simple. So 0 times x, y plus z is equal to 1, right? So if you equate, you will have y plus z is equal to 1. This is the first equation, right? 0x, y, z. So this will be a tuple. This is a tuple. Both the tuples are equal. That means the corresponding elements are same. So here the first element is 1. Here the first element is 0x plus y plus z. So that means y plus z is equal to 1 is the first equation. Now what will be second equation? X plus 0y plus z. So that means x plus z, right? X plus 0y plus z is equal to minus 1, right? X plus z is equal to minus 1. X plus y plus 0z is equal to 2. X plus y is equal to 2, right? So you need to solve these equations, find the x, y, z, substitute back here, it will satisfy that equation. So that x, y, z will be the first column in the required matrix, right? Okay. So very simple, right? You mark this as equation number 1, mark this as equation number 2, mark this as equation number 3. Now you need to solve these equations, right? Very simple. So what I can do is, if I subtract these two, x will get cancelled. So we will have an equation in terms of y and z, and I can equate this with and I can simplify with equation number 1 to get the value of y and z. So what I can do is, I'm just going to subtract 3 minus 2, right? So if I subtract 3 minus 2, I write it here. So if I subtract 3 minus 2, right? we subtract 3 minus 2, x will get cancelled. Here we will have y minus z, right? Here we will have y minus z, and we subtract this, 2 minus of minus 1 will be plus 3, right? Call this as equation number 4. Now you just solve 1 and 4, you can find y and z. After finding y and z, you can easily find x, right? Now solve 1 and 4, right? Now solve 1 and 4. So solve 1 and 4, right? So what is 1? So 1 is y plus z is equal to 1. Y plus z is equal to 1. And wait a minute. So 1 is y plus z is equal to 1. And what is 4? What is 4? So 4 is y minus z is equal to 3, right? Y minus z is equal to 3. So we have y minus z is equal to 3. Now if I solve this, these two will get cancelled. So we have 2y is equal to 4. This implies y is equal to 2, right? This implies y is equal to 2. And substitute back, very simple, right? Substitute back in any one of the equation. So from 1 we have y plus z is equal to 1, right? And since y is 2, we have 2 plus z is equal to 1. That means z is equal to minus 1, right? Now we know y and z. Substitute, we know y and z. We need to find x, right? So from 2 we have x plus z is equal to minus 1. From 2 we have x plus z is equal to minus 1. So that means we don't know x, but z is minus 1 is equal to minus 1. So that means x will be equal to 0, right? So minus 1 plus 1 is 0. So we have x to be equal to 0, right? So we have x to be equal to 0, y to be equal to, so we have 2y is equal to 4, that means y is 2. We know y plus z is 1. So y is 2, that means z is equal to minus 1. And we have x plus z to be equal to minus 1 here. So that means we have x to be equal to 0, right? So very simple. So we have found x to be equal to 0, y to be equal to 2, z to be equal to minus 1. So that means, okay, let us write it here, right? So that means the corresponding xyz that we need to do, that is 1 comma minus 1 comma 2, 1 comma minus 1 comma 2, right? So we need to express this as a linear combination of basis element in the codomain space. So 0 1 1 1 0 1, 0 1 1 1 0 1 plus z times 1 1 0, right? 1 1 0. So we have found, right? We have found x to be equal to 0. So 0 times 0 comma 1 comma 1, and we have found y to be equal to 2. So this will be 2 times 1 comma 0 comma 1, and the z is minus 1, 1 comma 1 comma 0, right? So that means the first column of the required matrix is 0 2 minus 1. First column. Now corresponding output matrix will be a 3 by 3 matrix, right? Corresponding output matrix will be a 3 by 3 matrix, because this dimension is 3, this dimension is 3. So output will be a 3 by 3 matrix. So in 3 by 3 matrix, the first column is 0 2 minus 1. Now similarly, you need to find second column and third column. You need to follow the same procedure. What I have did here, first I have taken the first element in the basis, right? So 0 1 1, and for that output vector, I have expressed as a linear combination of basis elements in the codomain space. Similarly, you take second element and you take third element, you will have second column and third column, right? Very, very simple problem. You can also verify whether it is correct or not, right? So if you multiply this, you will have 0 plus 2 minus 1. So 2 minus 1 is 1. So we have 1. 0 plus 0 minus 1. So we have minus 1. 0 plus 2, 0. So we have plus 2. So therefore our answer is correct. Now similarly, you take second element. Similarly, right? So similarly, you just take the second element. So 1 0 1, right? So you just have to find the output vector of 1 0 1. So what I have did here, I have taken the first element, right? Now you take second element in the basis of domain space. So here you have to take the domain space basis. You need to express as a linear combination of codomain space basis, right? So here domain space, here codomain space, here both are same, and they give only one basis. So therefore, I have taken both the bases to be equal to same. Okay, very, very simple. Why I am stressing, because in exam point of view, they may give different basis for domain space as well as codomain space, right? So for domain space, you need to input that element. You need to express this as a linear combination of codomain space, right? That is what I'm stressing here. If you have seen my linear algebra videos, you would be quite clear, right? Okay. Now T of 101, right? So what is our map? Our map is A plus B, A plus B, A minus B. So A plus B, A is 1, B is 0, C is 1. A plus B, A minus B, 2C, right? 2C, 2C. A plus B, A minus B, 2 times C. So this is 112. 112. Now you need to express this 112 as a linear combination of elements of bases in the codomain space, right? Here we have 1 minus 1 2. Here we have instead of 1 minus 1 2, here we have 1 1 2, right? So same procedure. So we will proceed. So we will do this. So we need to express this 1 comma 2 as a linear combination of the elements of basis of codomain space, right? So here both are same. So 0 1 1, 1 0 1, 1 1 0, right? So 0 1 1, 0 1 1, 1 0 1 plus z times 1 1 0, right? Z times 1 1 0. So similarly, you need to follow the same method, right? You need to follow the same method. So just you will have a system of equations again. Solve the system of equation. You find the x, y, z. That will be the second column. That will be the second column. So here, if you equate this, we will have x plus 0x, y, z. So we have y plus z to be equal to 1. And here we have x plus 0y plus z. So we have x plus z to be equal to 1 again. And here we have x plus y plus 0z is equal to 2, right? So call this as 1, call this as 2, call this as 3, right? I'm going to follow the same procedure here. If I subtract 3 minus 2, I will have an equation in terms of y and z, and I can solve with equation number 1 to find the value of y and z, right? So same method. So I'm going to subtract 3 minus 2. If I subtract 3 minus 2, so x will get vanished, y minus z. So we have y minus z, right? 2 minus 1. So 2 minus 1 is 1. Call this as equation number 4, right? Now solve 1 and 4. Now solve 1 and 4. So what is 1? So 1 is y plus z is equal to 1. And we have y minus z is equal to 1 from 4, right? So if I add this, we have 2y is equal to 2, right? 2y is equal to 2, right? So 2y, 1 plus 1 is 2. So this implies the value of y is 1, right? The value of y is 1. And we know y, and we know x plus y is 2, right? And we know, so we know, actually we can, very simple, right? So we know y is equal to 1. Substitute back in 1. So from 1, we have y plus z is equal to 1, right? Y plus z is equal to 1. And since y is 1, we have 1 plus z is equal to 1. This implies z is equal to 0, right? Because if I move 1 to that side, we have z to be equal to 0. And we know y and z. So from 3, we can find x, right? So from 3, we have x plus y is equal to 2. X plus y is equal to 2. And we know y is 1. So that means x is equal to 1. So we have found x, y, z. So x is 1, y is 1, z is equal to 0. Very simple. Substitute back here. So x is 1, y is 1, z is 0. Right? Super. So therefore, this 1 comma 2, we need to express this as a linear combination of elements of bases in the codomain space. So this will be x times 0 1 1 plus y times 1 0 1, y times 1 0 1 plus z times 1 1 0, right? Z times 1 1 0. So therefore we have found, right, x to be 1, y to be equal to 1, z to be equal to 0. Right, you can verify. So if you multiply 1 here, so 0 plus 1 plus 0. So we have 1. So we have 1 here. 1 into 1 is 1, 0, 0. So 1 plus 0 plus 0, which is 1. 1 into 1 is 1, 1 into 1 is 1. This will be 0. So 1 plus 1 is 2. So we have 2 here. Therefore, this will be the second column. This will be the second column in the required matrix, right? Now we have found first column. What is the first column? The first column is 0, 2, minus 1. Now we have found second column also. Similarly, to find third column, you input the third element in the basis, the domain space, right? Now similarly, you just find T of, so what is the third element here? What is third element here? 1, 1, 0, right? 1, 1, 0, 1, 1, 0. So what is the map? What is the map? A plus B, A minus B, 2C. So A plus B, A minus B, 2 times C. So this will be 1 plus 1 is 2. So 2, 0, 0, right? So A plus B, A minus B, 2C. So you need to express this 2, 0, 0, 2, 0, 0 as a linear combination of elements of basis in the codomain space. What is the basis of codomain space? So they are given only one basis. So take that as a basis for domain space as well as codomain space. So 0, 1, 1, 1, 0, 1, 0, 1, 1, 1, 0, 1 plus Z times 0, 1, 1, 1, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1, 0, 1, 1, 0, right? Super. Now similarly, you will define the x, y, z. That will be the third column for the required matrix. That will be the third column for the required matrix, right? So if we equate this, you will have 0x, y plus z. So we have y plus z, right? We have y plus z to be equal to 2. Call this as equation number 1, right? I'm just equating, that's it. 0x, y, z. So you will have a tuple here, you will have a tuple here. Both the tuples are equal. That means the corresponding entries, corresponding pairs are equal, right? So we have 0x plus y plus z is equal to 2. And here we have x plus z. So we have x plus z is equal to 0. Call this as equation number 2. Here we have x plus y plus 0 is z. So we have x plus y to be equal to, equate with this, right? You will have this to be equal to 0 again. Call this as equation number 3. Solve this equation, you will find the third column. Again, I'm going to follow the same procedure because all these equations are same. The only thing that varying is the output vector, right? Okay. Now similarly, I'm going to follow the same method. Now subtract 3 minus 2. So if we subtract 3 minus 2, x will get cancelled. We have y minus z, 0 minus 0. So we have y minus z to be equal to 0. Call this as equation number 4. Now solve 1 and 4. Now solve 1 and 4, right? Now if you solve 1 and 4, we have y plus z. Y plus z to be equal to 2. And we have y minus z to be equal to 0. So this will get cancelled. So we have 2y is equal to 2. This implies y is equal to 1, right? Y is equal to 1. Now substitute this y back in equation number 1. Now from 1, we have y plus z to be equal to 2. This implies, so y is 1. So 1 plus z is equal to 2. This implies z is equal to 1, right? So if you bring this 1 to that side, we will have 2 minus 1 is 1. And we know y and we know z. Now from 3, we have x plus y to be equal to 0. And since y is 1, so we have x plus 1 is equal to 0. This implies x is equal to minus 1, right? So we have found the corresponding x, y, z. So therefore, this will be the third column in the required matrix, right? X is equal to minus 1. Therefore, the corresponding x, y, z are, that means this 2, 0, 0 can be written as, so we need to express this as 0, 1, 1 plus y times 1, 0, 1 plus z times 1, 1, 0, right? Z times 1, 1, 0. And x is minus 1, 0, 1, 1. And what is y? Y is 1, 1, 0, 1. And what is z? Z is again 1, 1, 0, right? You can check this whether it is correct or not. Minus 1 into 0 is 0. 1 into 1 is 1, 1 into 1 is 1. So 1 plus 1 is 2. So we have 2 here. Minus 1 into 1 is minus 1. Here we have 0. Here we have plus 1. So minus 1 plus 1 is 0. So we have 0 here. Here we have minus 1 into 1 is minus 1. 1 into 1 is plus 1. So minus 1 plus 1 is 0. Here we have 0. So that means correct, right? Therefore, this is the third column, right? Therefore, the required, therefore, the required matrix for the given linear operator right? So the matrix for the given linear operator with respect to the basis, right? With respect to the given basis B, the matrix of T with respect to the given basis. Yes. Now, in the very first input, if you input the first element in the basis of domain space, output is 1, 1, 2. You need to express that 1, 1, 2 as a linear combination of elements of basis in the codomain space. What we have got? We have got 1, 1, 0, right? 1, 1, 0. Remember, this x, y, z that we are finding, that will be the corresponding element of the first column, right? So don't simply write this 1, 1, 2. You need to express this 1, 1, 2 as a linear combination of elements of basis of codomain space. I'm telling this often because it's very important, right? Okay. So therefore, the first column is 1, 1, 0. So 1, 1, 0, 1, 1, 0. And what is the second column? For second column, we need to input the second element in the basis of domain space. Output is 2, 0, 0. You need to express this 2, 0, 0 as elements of basis of domain, the basis of codomain space. So x, y, z is minus 1, 1. Sorry, this is third input, right? Okay, sorry. The first input vector is 0, 2, minus 1, right? For linear operator, so is given by so the matrix of T, right, with respect to the given basis, right? So the matrix of T with respect to the given basis B. So what is the first column? So the first input vector is 0, 1, 1. Output is 1 minus 1, 2. We need to express this output vector as a linear combination of elements of basis of codomain space. So what we have got? So we have got x, y, z to be equal to 0, 2, minus 1, right? So 0, 2, minus 1 will be the first column. 0, 2, minus 1, right? Now similarly, what we have did? We have inputted the second element in the basis vector of domain space, which is 1, 0, 1. Output is 1, 1, 2. We need to express this 1, 1, 2 as a linear combination of elements of basis of codomain space. So what is the x, y, z that we have got? We have got 1, 1, 0, right? Yes, 1, 1, 0. So that 1, 1, 0 will be the second column. Now similarly, we have inputted the third element in the basis of domain space. Output is 2, 0, 0. We need to express this 2, 0, 0 as a linear combination of elements of basis of codomain space. Why I am stressing? Because this is very important, right? Because you need to express this output vector as a linear combination of elements of codomain space only, right? Okay. Here our domain space and codomain space are same, and also they are given only one basis. In that case, you take same basis for domain space as well as codomain space. Suppose if they give two different bases, means you take the basis of codomain space and you express that as a linear combination of this output vector, right? Very simple. Super. So what we got? We have got 1, 1, 0, right? 1, 1, 0, right? This second input vector is 1, 0, 1. We need to express that as linear combination. So we have got 1, 1, 0. So 1, 1. Okay, I've written 1, 1, 0. Now what is the third? Third is 1, 1. Third input vector is 1, 1, 0. And if I express that as a linear combination, we have got x, y, z to be minus 1, 1, right? Minus 1, 1. So minus 1, 1, 1. So this is the required matrix for the corresponding linear operator, right? Very, very simple problem. It will take time, but if you have did a very good practice, you can do this in maximum of 10 minutes, right? Very simple. You just have to solve this equation. If you know how to solve the first equation, then the remaining two are very, very easy, right? So we have solved the second problem. Now in the next class, we will continue with the third problem, right? So I'll just post all my lectures in the description box. So go through that. If you haven't downloaded our app, you can also download our app, right? So we'll see you in the next class. Next problem. Thank you. All the best.